I'm going to continue to do what I was trying to do yesterday or some days ago. I spent a bunch of time studying. It took me a long time. I overlooked the position thing. I was trying to figure out how the position of the object 3D is related to the way that they update on the GL position inside of the vertex shader. So this is the shader that they use to the one that I was using. So there's a bunch of different shaders that they use, but I just put all the codes for the shader that they use on the mesh basic material on one file to make it easier to build or try to build the beginning of the thing that I'm trying to do. So first I'm trying to simplify everything. So I just get the stuff that I need from Three.js, which is from Threepp, which is the Three.js C++ version of Three.js. So this is how they update the gel position inside of the shader based on the one that I was using. And then this MV position here is going to be this transformed. And this transformed is this position variable here. And they add this as a prefix on one of the classes, the high level classes that they send the data to or they do some string manipulation to create the shader to actually build the program. So I was trying to figure out at what point during the rendering cycle do they use this position, or do they update the position? But then I realized that I overlooked that they are not actually, like, this position here is just gonna be the data that they send through the buffer geometry, and the way that the position on the high level, which is this one here, was the way that I was changing the position of the object. So from the higher level class, which is the mesh, you just update the value of the position, which is the mesh inherits from the object 3D, which is a vector tree. And then I didn't understand how, I wasn't understanding how this position is related to the GL position on the shader. But then I figured out that I overlooked on one part there that in the very beginning, actually, they call this update matrix world on the scene. And then this function called this one, and this one uses the position of the object. So it's on the very beginning that they are updating recursively everything. So now I feel like I understand much more, but there's still a bunch of stuff that I have to do that I'm not really sure how I'm gonna do it. So I'm going to try to figure out this today. So maybe I think I'm gonna show the SkyDraw stuff first. So the goal that I have is to simplify everything because I only wanna keep this stuff. The thing that I'm gonna do is also create other files here, so I can just try to simplify as much as possible the shader as well. Just remove all this stuff that I don't think I'm gonna need. I'll keep the other one as a template in case I wanna do other shaders in the future. I'm probably gonna use these ones, and then I'm just gonna go over the shaders and go over this code and remove all this control flow here based on the variables that I think I'm not gonna use. So it's very confusing the way that they did it, and I'm not 100% sure if I'm gonna be able to simplify or not, but I'm gonna try my best, and that's what I'm gonna do now. I'm going to create another renderer file. I think I already created here. They use a pattern. Apparently, that's a lot of people use this pattern, which they create kind of like an interface between the class header and the implementation of the functions. And they do it through this variable here, which they initialize on the class, which is a shared pointer. So it's called pointer implementation. That's why it's written like this. And apparently it helps, if you're building complex libraries, it helps to simplify everything, so that you don't have to recompile a bunch of stuff every time you change something on the class. But it does make things a little bit more confusing, so I'm not really sure if I'm gonna leave it like this or change. But I've been removing or trying to remove as much stuff as possible from this class, and so I can just put the stuff that I think is gonna be necessary to render the stuff that I'm trying to render. Then one idea that I had as well is to try to extract everything that all the GL functions that they call, and then try to rebuild just with the GL code, the pipeline, removing all the complexity of the classes. So I can think about how to create the actual program class that is gonna render everything. Yeah, so from the main class, they specify the functions like this, and then they inside of these functions they just call this other thing here, which is the struct. It's gonna have the actual definitions of each function. So every time, this is kind of the annoying thing about C++ as well, is that every time I want to put another function here or remove a function, I'm gonna have to add the declaration on two different places, and then put the definition on the other one, which is kind of confusing. It leaves more space to make mistakes. And the other thing that is kind of annoying, and I'm a little bit on paralysis by analysis now, because I'm only gonna be able to know if the stuff that I'm doing worked or not once it gets time to render the things. But the problem is that if I get to the point that I realize there is something wrong, it's gonna be very hard to debug. So I'm trying to think about what is the best way to go about changing things or trying to implement everything. So I remove a bunch of functions. I think I'm gonna show on the schedule draw the stuff that I did there. For some reason now it's not going to these functions. At some moment it stopped going to the definition. I'm not really sure why. It might be like a problem with the declaration here, because I changed some things. So the way that they were doing, and it's kind of confusing to me, like they were mixing a bunch of functions related, a bunch of classes related to managing the buffers with the renderer class, and I'm not really sure if that makes sense or not. But the way that I'm thinking about doing is just passing all the, or I'm gonna try to probably do everything again from scratch. Well, I'm not really sure if that's gonna be too much work, but on their version here on the renderer class, they have a bunch of functions, a bunch of classes here that they handle the management of the geometries, the materials, and the variables use the insider of the shader, which is these attributes here, and the uniforms, which is inside of one of these classes. And then they have this other class here, which also is used to update and create the buffers. So it gets very confusing because of this. It's like it feels like everything is mixed. So this objects is the main one. I'm gonna show on the schedule draw there the stuff that I did. I'm gonna go from here probably, because I have to clarify what's the way that I'm thinking about doing is just looping over the objects. So have control flow in the beginning to see if it's the first time that is calling the render function. If it is set up the programs. So I'm gonna have a programs class, and the programs class is gonna have a map. So pretty much this way here. Have the renderer, it has programs, and then it maps. But here I realize that's probably better to do mesh ID, because the mesh is the thing that is actually gonna be the program. So it's gonna be analogous to the program. But this is the part that I'm not really sure, and that's why it's hard, because there's so much things. Like the higher level is intrinsically connected with the way that the shader works. So it feels like I have to do those two things at the same time. It's kind of confusing. Because the way that they do it on 3GS is to select the shaders based on the material only. But the thing that is actually being rendered or being used to create a program is the mesh. And the material is passed through the mesh through dependency injection. So it's kind of confusing. And the thing that I spent a bunch of time trying to figure out as well is how is the geometry related to because I wanted to understand how the position is being updated. So I wanted to understand how the geometry of the class you use, which in my case, I think the first thing that I'm gonna try to render is the sphere geometry. So I wanted to understand how the attributes or how the sphere geometry class is related to the gel position inside of the shader. And that's the part that I don't like the way that they did it because it's very confusing to understand what's going on. But they pretty much put the control flow based on the functions that are related to set up the programs in the main loop, and then those functions are gonna call the other classes that have this gel objects and the gel geometries, and then eventually is gonna use the data that sets up on the geometry class to update the buffer, which is gonna pass the data to the shader. But and this is kind of the thing because the reason why I don't like it might be because I just don't. There's two things. One is that the way that they design the class is like having a lot of use cases in mind. So like this is one reason why it might be this way, which I have to think about because I might want to do other things later on with this. So I want to be careful to not make it so that I design things in a way that is going to be hard to change later on. But at the same time, it might be that there is just a better way, and the reason why they did it like this is just because of the way things evolved. So, and usually that's the case for like big corporations, for let's say, because like once you make, it's kind of like building a building, because you don't know, because of the nature of how we build things, you don't know how the building is going to look like, and it's like a skyscraper. As you build the building, you're going to realize that you made some stuff that is not very good, but then at that point it becomes very hard to change the foundation of the building because I already have a bunch of floors. So it might be one of the reasons why they did it like this, like because there's a bunch of people working at the same time on the same thing, and then based on the way that the nature of the way that the thing evolved, it became like that, and so it might be better to change, but maybe not. So not really sure. That's the way that I'm thinking about. So on the function that I create the programs class, which is gonna have this unordered map between mesh ID and program class. Each program class is gonna be related to the mesh ID, and I'm only gonna render meshes because I think that's what I need. And as I create the programs, I think I'm going to create the program class. Select shader based on material type. So yeah, inside of this, I'm probably gonna keep the same logic that they did because but I'm not really sure about this as well. Maybe I'll change this. But it seems that the material is the most important thing to select different shaders, because probably the way that you calculate the positions don't change very much. So one vertex shader is more generic than the fragments because the main thing that is going to change is probably the lighting and stuff like that when selecting multiple different shaders. So it makes sense that the fragment would change more, and if the fragment changes more, then it makes sense to select the shader based on the material type. Initialize program class with vertex and fragment shader. So that's what I'm thinking about doing. So after I select, because yeah, I'm gonna have to do both the mapping and the creation of the class on the same function because it makes sense. Because I need to know the vertex and fragment shader that I'm gonna use to initialize the program class. So I'm thinking about initializing the program class with passing the vertex and fragment shader as arguments. And I'm gonna try to keep everything on one file so I don't have to put all this extra logic to create the shader code from multiple different shaders. I think it makes it easier to understand. Maps that shader class with material ID to cache programs. Then on this program class, I'm thinking about putting all these other classes, or I don't think I think I'm gonna avoid doing. Well, maybe I have to because that's the way that they did it. But the way that they did it is they put these classes here that are related to the program on the renderer class. That's the thing that is kind of confusing. And then they have the other classes to manage this stuff here. And you need to use some same classes. I can create this class based on the variables of the shader. Initialize class parameters that determine. So this is the stuff that I think that's yeah, the control flow that I was doing by following the render cycle from them. So it seems that project object is mainly used to put the items on the render items list, which is going to be the thing that they use later on to decide what to render, which I don't like as well. I think I'm going to change the functionality from the project object to just render everything as it traverses the scene. But I'm not really sure if that's good or not as well. Because then it goes to the thing that I don't understand very well. Like maybe they did this for a reason because it's better to put everything onto a list first. Because there's some situations where it's better to render or give the option to render one thing before the other. So, but the other thing that I can do, actually, I don't even need this stuff now that I think about it. The one that I have to traverse the scene is when creating the programs, I think. And so maybe that's what I do. The very beginning, I traverse the scene. Then I put all the meshes on a list, and then I loop over the vector, and then I loop over the vector, and then I create the mapping of the programs with the mesh ID, and then I use the same thing to render everything. Whatever. So this one, they have the GL objects, which is another class. Then they call this GL geometries. So this class has this one as an attribute of it, and then it calls that class, and this class has this buffer geometry, and the buffer geometry has this other one. It is looping over this. So this is the attributes from the buffer geometry. And the attributes, I think, they are this typed buffer attribute, which is another class they use, which is the class that is actually gonna handle the attributes of the shader. So let me show the code. So at the end here, I only seen for the sphere geometry, but I assume that it's gonna be the same for all the other classes. So the way that they do it is that they create all the points, which are gonna be vectors. Here, apparently, they are doing on a linked list, and I'm not really sure why. This is the other part that is kind of confusing to understand because there's like so many steps in between these parts and the creation of the actual shader. But yeah, they create these linked lists and then they create all the points based on whatever control flow is going to create the shape you want to create, which is in this case going to be the sphere geometry. And then they are pushing that or appending that to the linked list in the end. I think it's here. Yeah, so here they insert all the points. So this becomes a giant linked list with all the where each node of the list is a vector that is the point, as far as I understand. Then after they do all that, then they call this functions here. And then this is the function that creates the sets attribute on the buffer geometry. And this is the typed attribute function. So it creates a typed attribute based on this function here for each one of the linked lists that has the data. So this is going to return a unique pointer to this class here. And then this function is from the buffer geometry. So it's just creating attributes inside of the buffer geometry that has the name as position. And the data is going to be this typed attributes that is going to be based on the data. So it's just creating this map. And then later on, it's going to use that to update the shaders. So yeah, I think this is the flow here. So from the render, they have the GL objects that has the GL geometries. the geometry says, which is a mapping, I think, from the geometry. This is the part that is kind of confusing. I have to go back to see. I think here they're getting the attributes here, all the attributes that the geometry has. So in the case of the sphere, would be this tree here, I think. And they map based on key value pairs. These I forgot where the functions are. I have to go back to go on the flow of the execution again. So they loop over this, and then for each one, they have this other class that is part of the geometry class, which is GL attributes. So I think that the GL geometry keeps track of all attributes that the geometries have. And then it calls this update function and then passes the current attribute inside of the loop. And this is the function that either creates the buffer or updates them. So, but like that's kind of the problem there, because it seems very confusing. And then they have these other buffers here, which is a struct, and then inside of the struct they keep track of the buffers. So I'm not really sure. I'm thinking about trying to do everything from the beginning. It's just going to be easier. And then those are the actual GL, OpenGL functions that they call. So these ones here first, and then this one. These attributes, the attributes, these ones are this data structure. So it's just mapping the name of the attribute with the buffer attributes, which it creates in the beginning of on the constructor of the geometry class. And this is the buffer struct. And then here I just wrote down like the functions that they use. But there's like, because I was thinking about doing from the beginning. Not really sure though. So I'm gonna have to spend a bunch of time going over the source code again. So let me go. I'm going to try to. So I'm probably gonna delete this thing here. I'm gonna copy this other function again. I removed this one because of the stuff that I just said. I'm thinking about moving the functions to the other classes. So I'm going to create the gel programs first, and then I'm going to try to follow what I'm thinking about. And once it gets time to create the other stuff, then I'll do that. Then I'm gonna have to go over the source code, spend a bunch of time trying to understand how. I probably at that point I'm probably gonna remove the like a bunch of code from the inside of the shaders, just basically like, intuitively uh, from what I think I'm gonna need from the shaders, because that's gonna make it easier to think about what kind of logic I'm gonna have to have inside of the program to have access to those things. I'm gonna put this thing back there. I'm just gonna remove this things from here. Oh, it's render. I also removed these things. I'm not really sure if I'm gonna need, but I think that the reason why they, as far as I understand, OpenGL clips everything for you. After you calculate the gel position on the shader, OpenGL is gonna take that, then it's gonna clip everything, and then it's gonna do the perspective divide. Then after that, it's gonna convert from normalized variance coordinate to string space. So I think that the reason why they put this thing here on Three.js is just because if you have a situation where someone wants to clip something else or like put some logic to clip in a different way, but I don't think I'm gonna need that now, so I'm just gonna remove. I'm gonna try to remove everything that I think I'm not gonna need, because then I can build from only the stuff that is necessary, and then once I get to the point where I'm trying to uh, visualize things, then I'm gonna have ideas on other stuff that I can do, and then I can add complexity. Just simplify it and add complexity later. I think you can get rid of all this stuff. So this background I'm gonna need, and so I'm just gonna copy the background and the programs. Let me think about it. Oh, the other thing that they were doing is this frustum here, and they are creating another projection matrix inside of the render class to cache the projection matrix from the camera. I think the reason why they do that is because there are situations where you can have multiple different cameras. So, but I think I'm gonna remove all of this stuff, and then later on, if I want to do something like that, I'll think about it again. So I'm probably gonna remove the frustum thing there. So it's probably better to just start from the place that I want, and then as I need things, I add them to the class, to the classes. So this is another thing that's kind of confusing, but now I think I understand. So this count here, the position is gonna be the index I don't know very well. Let me see. I think the position is the buffer attributes. Maybe it can go here. That's from this thing here. So it's from the buffer attributes. And the count is just how many points you're gonna have on the vector. Which I think is a linked list actually based on the class. But it's pretty much, but I think it converts the linked list into a vector once it creates the attributes. So what it's doing is pretty much getting the length of the vector and then dividing by how many, by the size of the data you have. Because it can imagine that different situations are gonna have vectors of 2 or 4 or 3. So you're just dividing to get how many points there is on the vector. So that's pretty much what it's doing here. And then this range here is gonna go from 0 to this, or this other thing here that I don't understand very well. But I think that this is for when you have the groups. I'm not really sure what the range vector factor is for as well. And then I assume that the draw count is just gonna be from 0 to however many points you have. And this is used to pass on the GL render function at the end here. GL, which is gonna depend on which kind of thing you have there as well. So all this stuff I'm gonna remove as well because I'm only gonna render meshes, I think. Because based on the stuff that I have there on the project that I was doing, I only have meshes that I'm rendering, I think. So, no. And this class, the binding states is the one that has some functions that's like the ones that are familiar to me are the ones that structure how that tell OpenGL how to make sense of the vector of data you're passing so that it creates the structure you want. So it replaces the values of the variables. And it's probably better to just I don't even remember what I was trying to do here. Maybe I don't even need this background class. But maybe it's a good thing to do. And the example that they share there, this is gonna be no, I think. It's gonna be this thing here. Because they don't initialize the background on the scene. So if it is no, it's just gonna call an OpenGL function to clear colors. So I think I can probably replace this with the, and then I can put another variable if I want, probably. Like I can put a variable inside of the scene that's, or maybe there's an enum that I can use or something like that. The term is the background color, and then I don't need this class, I think. So I'm probably gonna remove that from the other one. And then they're using this, which is another confusing thing. They're using this state variable, which is gel state, I think. The class is another class that they have. And that class I removed because from what I've seen is just related to other stuff. Because I think that they keep track of different states of what's being rendered with a stack. And then they use a list to loop over the stuff that each state has to render. So there's a list of things that you render, and then there is a stack, which is a different potential lists you can have if you want to render multiple different things. I think I didn't understand that part very well, but I'm just gonna remove all of that. So, but what matters is just obviously the GL functions that they are using, so I can use the same. So I'm probably gonna remove this stuff here from the other. Just gonna remove the background. I also wrote down here the thing that actually matters, the way that they are doing things, should update the variables on the shader, as far as I understand. So let me see. Position attributes initialized on the geometry class through the buffer geometry set attribute function, which is the part that I was showing there in the beginning. The updated position on the shader is the multiplication by the model view matrix and then projection matrix, which is the part on the shader code. Both model view matrix and projection matrix are updated on the render cycle. It's on render objects. So model view matrix is the matrix that holds the information of the road position of the object multiplied by the camera. And the road position of the object is just the multiplication of its local matrix with the parent matrix, if it has any parents. If it doesn't have parents, then they is the same matrix. So it's pretty much the same way that the OpenGL tutorial there talks about, which obviously makes sense. But there's a bunch more complexity for the other stuff. But they do this part outside of the shader, which I think it makes sense as well, like because of the nature of the thing. And then they pass the model view matrix variable through the shader. And I think they do that here at this on the set program function. The singing children are updated in the very beginning of the render cycle. This part here. So this function is the one that I said that I missed, that because this function is going to use the position of the object 3D to update the value of the matrix. So it just updates the current matrix. So this one, I think that it stores the result here and multiplies this matrix by this. So it's multiplying the road matrix from the parent with the current local matrix for the object 3D. And then it's storing on the matrix road. And then it's calling itself recursively. So it does that for all the children. So because it calls on the scene, it's going to update everything. And yeah, this is the function that it updates the local matrix and uses the position, the continuum, and the scale to update the local matrix. So if you change if you want to change the position of the actual object, what you do is just change the position of the vector. So when you call on the mesh, it's calling that position. So that's why it works. When you change this position, you're just changing the calculation here, which changes the local matrix, and the local matrix changes the road matrix for the current one. And it does, so it updates all the scene and the children of the scene, which are going to be the meshes, and then updates the camera. So it's pretty much the same function, but then for the camera. And then inside of this, it's actually later on I deleted the function, but then it's going to do the other calculation, which I think is this one. And this is on the object 3D as well. So each object 3D, which is each mesh, is going to have this model view matrix as well. So on the render object function, it calls this function here, this function, which is multiplying the inverse of the road in the camera with the road coordinates of the object. So just transferring the road coordinates of the object through the lens of the camera and storing that on the model view matrix. And then this is the main thing. This is the projection matrix, which also comes from the camera. We're going to be the main things that are multiplied by the position inside of the shader to update the GL position. So it's pretty much this calculation here. So this model view matrix comes from these functions here, which happens inside of the render cycle. And then it multiplies this by the projection matrix, and I think it sets the projection matrix on inside of the set program function, which I'm probably gonna do in the very beginning. Like the first time that I'm gonna create a Boolean variable that determines whether or not it's the first time that I'm calling the render function. But this is another thing that I just realized now. I don't know how that works. And maybe that's why they have this stack in the list. Because I don't know if the render function calls itself recursively. No, I think that happens in the loop. Yeah. No, never mind. So you're only gonna call it once, but then on the outer loop, on the main loop of the the actual scene from the app, which comes from glfw. That's how it's gonna call multiple times. So I'm gonna put the render function inside of this loop here. So the first time I'm gonna have a Boolean variable that checks to see if the programs were initialized already, or if it's the first time that is running the loop, the render loop. Then if it is, I initialize the program classes, and then I initialize this projection matrix on the class that is gonna handle the attributes for each program, I think. So I'm probably gonna put this function inside of the, maybe it's better to, because it's gonna depend on the camera. So I'm not really, I think it's better to leave on the renderer, actually. Yeah, I'm gonna try to reuse the functions that they use as well, so. Scene children are updated in the very beginning of the render cycle. Updates matrix world or position of the objects or position seen through the camera lens. Of the camera. And then model view matrix on the shader. So inside of here is updating the model view matrix. And I think it's on the render. It's probably on this one when it sets the program here. So this is the position, which is the buffer. I think buffer attributes that has the counts that is gonna hold the data of the stuff that of the geometry. So this attribute is the position attribute inside of the sphere geometry. It's this one that sets on the beginning, which is the data you're sending to the buffer. And this is gonna determine the count there. So this is the thing that is not very clear, but I think that's how it works. Is it only sets the data once when you initialize the class, and then after that, the only thing that will have to change is the position of the object, and the scale of the object is gonna depend on the radius. But I think the thing that I don't understand is the coordinates, because it seems that on the sphere geometry, the coordinates are not on normalized various coordinates, and they have this normal here. And I think that at some point I've seen some comments saying that normal is related to, like, if you want to do something, it's not what I thought it was supposed to do, which is to normalize the coordinates to normalize vice coordinates. To take the coordinates of the vertex and normalize it. It's not the purpose. It's something else, but I don't remember exactly what it's supposed to do. So this part here is the one that I think that they update the projection matrix. So I think I'm gonna have to do this. So, and that's the thing that is kind of confusing as well, because it's related to the program, is the whole thing that I don't like. Because these are gonna, but just based on the names, I think that what's happening is that it's getting the uniform, which uniforms are the variables inside of the shader you use. So it stores that on this class probably, and then it gets the uniforms here, which are the variables. And then it sets the value of the projection matrix variable with the camera projection matrix. But it does that through all these functions here. So I'm probably gonna put this one inside of the main loop. The first time that it renders, I have the Boolean variable, and then set up the programs, and then after that I set up I think I have to set up. This is another thing that I have to think about, because now I don't know how they. I think they use they use different shaders for each thing that is gonna render, regardless of whether or not they use the same shader. So this is another thing to think about. Because if I have 3 different things that are gonna render, but they all use the same shader, then obviously it doesn't make sense to create a program for a different program class for each one. Maybe it does actually because you're gonna, yeah, it does make sense because you have to update the different. So regardless of whether or not the shader code is the same, I think you have to create three different programs. Yeah, that makes sense. Because you're gonna update the variables inside of the shaders in a different way. So I think, yeah, probably that's the way to do it. So I have to initialize each variable inside of each shader. So as far as I understand, the buffer you set up once, and then you only call functions to change if there is a change on the variable. This part's not clear to me. I remember seeing this function, which is very confusing as well. And this is kind of the whole problem with this. Like, so let me think. So let me think about the names. I'm going to start doing the thing from the beginning. So this part I'm going to leave the same. The ones that I'm going to change are these ones. So let me think about what I want to do. I need to have a Boolean variable here. What can be a good name for this? There's render. Oh, actually, I'm going to initialize the beginning here. I'm gonna try to do it in the simplest way possible, so I don't spend too much time thinking about it. And then that's probably a better idea. So instead of trying to spend a bunch of time on the questions of whether or not uh, or how to structure things, I just do the simplest thing first, and then see if it renders anything, and then from that point I think about if it's worth trying to optimize something. So actually, before this thing here, so this is the function that I have to think about. It's like how I'm gonna, what is the best way to traverse this scene? Because on the traversal of the scene, it makes sense to be recursive, I think. So I'm just gonna copy the same pattern of the project object, but I'm going to. The thing is that I'm not really sure if it's gonna be too confusing if if I do this part here instead of the function that is recursive. So maybe I can have another function that puts everything into a list or a vector, so it makes it easier to understand what's going on. I'll be right back. So I think it makes more sense to create the program, the mapping as I traverse through the thing. And I probably have like one function, and then inside of that function, I call the recursive function. Let me think about this. The question is the selection of the shader. I think I need to get the program's class first. I can call it, so it's probably, so the question is, do I need another function? Or can I do everything on, I think I can do it on the same. So I just copy this one. I put here. Hmm. So I'm gonna copy the same pattern from the objects. I'm just gonna replace the logic inside of the if condition. So instead of creating the render, so I thought about I don't need to create a vector if I have the mapping. I could just loop over the which programs I have inside of, so I create the unordered map inside of the programs class, and then I just loop over the map to render everything. So let me just copy the. I'm gonna copy, then I think about the other steps. So I'm gonna remove all of these things here. The one that I'm not really sure is this group, because I was doing with a group on the 3GS. So I'm not really sure how the group works with the mesh. Because the group itself doesn't have, is an object 3D, but it doesn't have any, well, maybe it has, materials. It doesn't show anything. So like when it's adding stuff, when you create a group and you add objects to the group, it's just using the object 3D add function that puts everything on the render. So that's kind of the thing, because the group is something that you can use to render stuff, but it doesn't have a mesh. That's the problem. If I want to do things the way that I'm doing now, like it wouldn't work. So obviously what I can do is just do the same thing for the group that I'm doing with the scene. So I get the meshes that are on the group. But I'm not really sure if that makes sense. Because as it traverses here, it should go over the group, because it's gonna go to the child of the group. So I think it gets it's gonna get all the meshes anyway on this function. So maybe that I don't need this part here, because this is just to determine. I think I'm gonna delete, because what is gonna happen, the way that I'm thinking about it now, that I think is gonna happen, is that it's gonna traverse through anything anyway, anything that is a child of the scene is gonna traverse, and then when it gets like it's gonna get all the meshes that are, regardless of whether or not they're part of the group, and then it's gonna create a map between the meshes and the programs that I'm gonna initialize here. And when I update the position of the group from outside, so the way that I'm thinking about doing, like I'm gonna do the physics based on the position, which I think is the easiest way to do it. It's gonna be based on this position here. So I'm gonna create a mesh, which probably gonna use the same function here. And then once I create the network and I'm going to update the positions of each thing, I'm gonna update it by just calling this copy here and passing another vector. So I run this physics simulation to calculate everything. then I update each position based on this. So the way that I'm thinking about it is by updating the position of the group and not the mesh. But what I think is going to happen is that it's just going to update the position on the object 3D, which is the object from the group. And because it's updating that position, it's going to update the other ones by default because the other ones are, the matrices are connected with the group. So I think it doesn't matter that much when it comes to the rendering. The only thing that matters is the mesh for the rendering. So I think I'm gonna try to do it like this. Just gonna delete this part. Obviously, if it doesn't work, then I can think about it. And then here, I probably was gonna put. Don't remember if C++ is like this or. These parts also not gonna use. And this one, I think I'm gonna is the part that I was talking about. But I'm not 100% sure because I don't understand very well why they use this frustrum. I think I deleted on this one. I'm not sure if it's done like this because WebGL is different or because it's some extra functionality like that they allow you to customize when something's gonna show or not. It's probably like better to just remove this stuff. Removing and then seeing if I need it is much better. This stuff is just for yes, something they were doing, I think, with the with caching the state of the camera or something like that. So I think I'm gonna remove all of these things here. So basically, the way that they were doing is just to because they were using this render list to decide what they're gonna render later, and they were using these two different classes, which I talked about there, geometry and the materials. I don't remember. So we're gonna remove everything. This thing I'm gonna leave then. It's probably like, is not gonna take too much work to make this work, and it's probably better to leave like this. I think that this is a class that I yeah. So so what I'm gonna do here is just select shader. It's probably also this is another thing. So maybe I have to set the variable. I think that's probably all that I have to do. So initialize all the meshes. So I'm gonna copy the programs class to this one. Then the other thing that I was thinking about doing is just create another flag variable. And I was thinking about doing it separately from this one because probably this one takes more work. So, but I'm gonna create another one that's, but I'm not really sure if I'm gonna do this now because I think that the approach that works better is to just remove as much as possible. And then as I need things, I add them because then it makes it better. Like it's already gonna get complex. So the more you can simplify, the better. But maybe I should write here. The question is the positions. But I think that the position doesn't matter. That's the thing. Because it is the thing I was talking about in the beginning is kind of confusing. That I think that the actual shader, the variables related to the shader code, they for the stuff that I'm thinking about doing, they are just initialized once the shader is created. Because the positions of of the data you pass don't change because they're positions related to the local coordinates of the object that creates the geometry. And then if you want to move the object in the scene, what you're changing is just the position of the object 3D. So it's separate from the shader. And it moves by indirectly based on this function here. Because when it updates on the next render cycle, when it updates the position of each matrix row, because the position of the class is going to be different, it's going to change the position of the object. But you don't need to change the GL position of the shader. So I think I'm not going to need to update the shaders after I initialize for the stuff that I'm trying to do now. So what else do I need to do? So I think I'm just going to copy the classes. Maybe I have to... I'm going to try to do it without thinking about the group here. And just... I can test later if it works or not. The other annoying thing now is that I have to put... Every time that I change something, I have to put here. So this is something that I was thinking about as well. That I'm not really sure. I think I'm just gonna have to do the way that I'm doing now because I have to start changing from the renderer class, and because the renderer class has all the other classes, like I don't see a way that I can. Maybe I can see if it compiles now, and then I add the other classes. Yeah, let me see if I can remove the because it's obviously much better if I can just update one thing at a time. I'm gonna remove all this code here. And later on, I'm going to just get from the other project I think what I'm gonna do is just transfer this code for the program class. The thing is, probably what's gonna happen is that the program class is gonna be too big, so I'm gonna have to create or to get the other classes. But I think it makes a lot more sense to. But this is the part that I'm not 100% sure because it depends on the way that the shaders are gonna work. So maybe I do it from the beginning. I don't even do the stuff that they did. But what I'm thinking is necessary is just to have. I need some functionality that is gonna allow me to get all the variables used inside of the shader. Some functionality that is gonna allow me to update each variable. And that's pretty much it, I think. And then the other ones that like the ones that are gonna manage how the data is used. Build the buffer, then which is kind of the annoying thing. So build the buffer in the beginning, then other functionality that just calls the draw calls after the thing is built. Yeah, but if I'm gonna use this, it's just gonna be inside of the program class probably. I'm just gonna delete everything. Probably don't even need this function. Maybe I should delete everything here, to be honest. Oh, this is kind of annoying though. 'Cause the thing is that I need to remember the order that I update each thing. So maybe I can transfer this loop, transfer these functions here, then delete this thing. And stuff I don't know, I don't understand very well how it works. I think it's like event listeners. Set up event listeners on the object, it calls the function before and after. Maybe I should remove this as well. Probably the philosophy of just putting stuff you need. I'm gonna remove these things as well. The viewport ones and the pixel ratio, I think I'm gonna leave because it's kind of annoying and it's more related to the size. But this is another thing I was thinking about. But the way that I'm gonna integrate both is probably to this window size struct that I just copied from this project, and I put here, which is a struct they use to get the size of the window. And I'm gonna probably what I'm gonna do is just initialize this struct outside on the main thing here, and then because I have to make this window size related to the stuff that is happening here, obviously. But I don't want to couple the class with the GLFW stuff, so I think probably doing like that's better. But I'll think about this later. And then these ones are used to set the GL viewport, I think, based on the size of the window. I don't remember if I deleted. No, no, it's 0. I'm just gonna leave these ones. So it multiplies the matrices, loops them. Pretty much what is happening. So delete. loop over programs math. So there is some code here, some points, I don't remember where, that loops over a map. So should probably, I can ask ChatGPT obviously, but I think I'm gonna try to find here. Hey, what's up? I don't really have an app. Uh, I'm trying to build the trying to find here. I'm trying to build this, but with C++. So the idea is pretty much to have to parse codes, then create a graph data structure, and then highlight the code with the graph. That's what I'm trying to do. But here is very slow, and I think that's, I'm not 100% sure, but intuitively I think it's probably gonna be better to try to do it with C++ and then use IAM GUI to create the GUI components, and it's gonna be a lot faster. So I was gonna try to find the map. I think I'm gonna follow the execution here that I draw. I think it's on objects. Nice here. Updates. I don't remember which one, but there's one of these that I think loops over a map. The ones on the website there, they are showing the abstract syntax tree of a Python program. Well, what I'm gonna do, what I'm gonna try to do first is to create a parse tree from, so like Python, the way that the Python interpreter or compiler, depending on how you look at it, works, is that they use something called a parser generator, which takes a grammar and transforms it into a parse tree. And then they use that parse tree to generate a bunch of code that is gonna create the abstract syntax tree. And the abstract syntax tree is the thing that creates sentences for the language. Then from the abstract syntax tree, you get, based on those functions that they generate with the parser generator, you're gonna get the intermediate representation of the code, which is just another way to represent the code. So you're taking from Python, which is the strings. So first you create the tokens, which are the words of the language. Then from that, you use the parse tree that is created from the parser generator, which is based on the grammar rules. Grammar rules are written in Beckel's new form, or something like that. So they take those rules from, they make up the Python language, the grammar for the Python language. Then they run through a parser generator and then create this parse tree. Then from the parse tree, and also they have another generator that creates a bunch of functions that are gonna transform the parse tree into an abstract syntax tree. So from the tokens, they generate this abstract syntax tree, which is the thing that is gonna generate sentences. Then from the abstract syntax tree, you create an intermediate representation, which is kind of like a generic version of assembly. And then from the assembly, then there's some, I think it's control flow graph that is created for running some optimizations. And then after you have that, after you do that, then you compile, and then you get the machine code. So what I'm trying to do is to understand how the parser generator works, so I can create the graph visualization of the grammar structure for Python in the beginning, then maybe other languages. It's kind of complicated. How much do you know about programming? Is this one? I hear. I'm just gonna copy this. As far as I understand, this is an order map. So I'm just gonna copy the structure and then replace the variables. I was gonna return this thing here. So now I think is a good time. I'm gonna comment everything out. Comment everything out, delete, then see if it compiles. Then if it compiles, then I add the programs and I have much experience of low-level languages. Do you understand how compilers work? Do you know what an abstract syntax tree is? Do you know abstract syntax tree? It's not that hard actually to understand. Um, the nuances are hard, but the concepts are not that hard. So like a programming language is just a very long string, if you think about it. Then from all that the compiler is doing is that it's taking a very long string and is transforming into a bunch of other strings. And then it's gonna use these other strings to create the machine code at the end. So all the compilers, I think most compilers do, they take a higher level language and then they transform it into assembly code. The way assembly code works is just a standard that is created based on the instruction set architecture of the hardware to determine what's going to happen when you have a sequences of characters or a word that is going to create a state on the hardware. So, for example, you have load function. So a load function is just a bunch of symbols from the point of view of the hardware. And every time that you get those symbols that represent that word, something is going to happen on the hardware. So it's just a standard that people created to encapsulate the sequences of zeros and ones in the hardware that are going to represent something, a concept, which is assembly language. So all the programming languages are doing, they're taking a huge string and they are converting that huge string based on a sequence of rules to assembly language, which is the common language that hardware uses. And then from that, they use another compiler which transforms the assembly into machine code. So during this process of converting the one giant string into its assembly representation, what you create is a graph that's based on the rules of the grammar. You're going to take that string and you're going to create other strings based on the rules. So if you can have a rule, for example, that determines that every time you have a string that has digits and numbers, you convert it either to a digit or to a number. So that you're breaking down the string based on the rules that you create. One of the first process is creating the words of the language, which are the tokens. And the other one is creating this abstract syntax tree, which is a tree data structure that puts all the tokens together in order to form the sentences of the language based on the rules of the grammar. And that's what an abstract syntax tree is. It contains the information of how the tokens should be connected with each other to create the sentences of the language. And then it is going to use that as it traverses the abstract syntax tree. It's going to take the tokens, form the sentences, and then based on the way that it forms the sentences, it converts it to the assembly version of the sentence, as far as I understand. But I don't know the details very well, so stuff that's probably missing. Project ideas? What thing do you like to do? Another thing I have to do is to think about how I'm gonna do the mesh ID. They do some IDs for some of the classes, but I think I'm not really sure if it's better to use the math UUID. That I think is a random generator or something like that of strings, or if I should use the others. They use, I think, static inline to create a variable that remains the same, but I'm not really sure if that's the best pattern. And it's kind of confusing the way that they do it, to keep track of the IDs of each object. But probably it's the best thing to do. I don't remember where I've seen this. I think it's on the material file. Yeah, here. And then this is declared is declared here. I don't understand that very well how that works, so. I think that the way that this works is that it creates a variable only one time during the execution of the program, static. And then every time that it creates the class, it updates by one here. But it's kind of confusing, so. Oh, I think I understand now. So this is yeah, it's confusing because I was confused the ID with the material ID, but I understand. So each class has this material ID, which is initialized only once during the execution of the program. And then the ID of each class is going to be that by one. But it's kind of confusing because, like, how does that work? Because you're creating different instances of different classes. So maybe it works because this is the base class. I'm not sure if I can do this. What I can do is create a variable like this on the programs. Yeah, I can create this variable on the programs class. Then from the programs class, I create a unique pairing for the meshes. Just practice data structures. The project of yours is very confusing to me. It depends. It really depends on what your career is about. Because curiosity matters the most. Everything else is secondary. So what kind of things are you interested on? Like there's an infinite amounts of different things you can do. To think about a problem you want to solve in the world, and then think about yeah. From that point, then you can start thinking about what kind of things would be probably good to do. I'm gonna write the comments so I remember. The issue with this approach is that the IDs are not gonna be ideally the IDs will be coupled with the mesh. So there might be situations where I want to remove one of the meshes from the programs for some reason, and then if I remove, like how I'm gonna make sure that I know what's the it doesn't matter because I remove the mesh, I'm gonna remove the program as well. But maybe it would be good for rendering in order or something like that. Maybe it could be on the scene stand. I think it's one of those things that doesn't matter that much. Shouldn't spend too much time. Then later on, maybe about it. Not that big of a deal. This stuff is gonna be inside of the setup here, I think. And then I don't need this. Let me think. The object is actually gonna. And this is the thing. I will have to map the mesh itself, not the mesh ID. That makes more sense actually. So I don't know. Yeah, but then that's the question. I think this is the reason why. So let me think about this. Like, it's better to map with the mesh because then I can access the mesh here. I have to access the mesh to update the thing, the model we matrix for the mesh. And what if it's a group as well? So let me think. The question that I have is that if I create another map and I map the mesh with the program, then how is that gonna work? Like, can I do that? Because I'm mapping a class on the order map. I'm not really sure if that complicates things because it would be easier if I could just map with a string, which is the mesh ID, and then I use the mesh ID to get the mesh as well. Well, that's the question. It's how to connect. No, I don't live stream daily. Simplest way possible is to I don't even know if the stuff that I'm building is gonna work or not, but it should try to visualize what's happening on code. Uh, yeah, that's pretty much it. So let's try to visualize how if the path from this code to assembly code, like what happens, and then try to extract connections of what happens on the code itself into a graph. So I'm able to visualize it because I think that's gonna make it easier to understand what's going on. And then I have other ideas as well, but I'm not gonna talk about them. No, I don't have Discord. I have Discord, but I don't share it anymore. Yeah. Maybe sometime in the future I'll do that again. Also, don't enter. I'll used to go on Twitter. Maybe I'll go back again, but I really don't like that. It's just a waste of time. So, like, but once I get to the point where I'm building stuff, I'm probably gonna go back to. I wanna post more there, but I need to get to the point where I'm actually shipping a bunch of things. I think I can delete this stuff. Be right back. I don't understand why I'm getting this error here. And I wasn't getting this error before. But the main thing that I'm thinking about is what is the best way to map these things. So I think I need both the thing is that there's a bunch of different ways. That's the problem. I don't understand why I'm getting this. I don't think putting class in here makes sense. He does that on some parts, but I think it just should give access to the things, but I don't think that's the issue here. Incomplete class. Fuck does that mean? Hmm. This one is just because of the way that I did the class art. I don't understand why if it works on the other projects. So the best thing to do is probably try to compile. I'm gonna get these errors. And some of these errors is just because of the ID. So, yeah, let me. I don't know. I think I didn't put this files here. Hmm. Interesting. Let me see if I can do it without this. Because this is because I moved the project to the other folder. Because obviously I have the GLAD here. So I think it's just an ID thing, maybe. I don't understand why they did it like this. Oh, no. There is errors here. Maybe just because I'm not adding or including them here. I think on the other one they don't include explicitly because the other classes are including these things. This probably should work now. Trying to see. This is the annoying thing that I was talking about, is that if I want to change one of them, I'm gonna have to change all of them. Like change the types to floats there. Trying to think about whether or not it's worth it. And the next thing that I'm trying to think about is whether or not, like, how should I resolve this thing here? What's the best way to do it? There's so many ways to. One other way would be to put the mesh instead of the program class. The other one would be to put all the meshes inside of a vector or something like that, and then loop over the vector instead. But that wouldn't be very good. And the easiest one, I think, is just to map the mesh, instead of the mesh ID, map the mesh with the program. But I don't know if that makes sense using the order map. So let me run this again. I think I might try to remove these warnings. Just by changing everything. Hmm. Nice. Now I have to think about. So either I start, I copy the programs class, and then start thinking about that, or I think about this mesh thing here first. I think it's better to just copy the programs class. I feel like I'm losing energy, so either should take a break or stop streaming now. This part's gonna be the most annoying one. So I'm probably gonna have to spend time thinking. So I think I'm gonna probably stop streaming now. 'Cause I need to just sit and spend a bunch of time thinking about what is the best way to connect the mesh with the program. And then I'm gonna have to spend a bunch of time just changing all of these functions here, removing a bunch of things that I'm probably not gonna need. It might be better to just remove everything and start from the complete beginning and just follow what I'm thinking about doing there. So maybe that's the last thing that I can do streaming. Just go over the source code for the shader, remove everything that I think I'm not gonna probably use. So I'm probably not gonna use this thing, not gonna use this, not gonna use these things. I'm gonna try to simplify as much as possible. Maybe let me go back, and it makes more sense to do one by one and see where it's used first, then I remove everything else. I think I'm gonna do this off stream. It's not gonna. I'm just gonna stop streaming now. So what I'm gonna do is just try to simplify the code as much as possible, based on the stuff that I don't think I'm gonna use on the vertex and fragments. Then I'm gonna spend a bunch of time. I think I'm gonna spend time trying to figure out first whether or not, like, what is the best way to connect or to get the mesh object here and connect with the program inside of the programs class. Then after I do these two things, I'm probably gonna remove a bunch of stuff or start from the complete scratch. I'm thinking it's probably better to just, like, do everything from the beginning. So I remember there are some tutorials I've seen that people creating shader classes to so I think I'm gonna try to do it from the very, like, without anything. Just create a simple class that gets a vertex shader code and fragment shader, and then based on that, creates start adding the logic to get and update all the variables inside of the shader and to build the buffers based on the data that I get from the other classes. So probably next time that I stream, I'm going to continue to do this. So I'm just gonna try to simplify as much as possible and clarify what I have to do. Then next time I try to start doing, or if I don't do it off stream, I start working on creating the programs. After I have the programs, then I can start testing, I think, whether or not I'm gonna be able to render anything. Yeah, so I'm gonna do the rest off stream. So.